Okay, this section is on 4.3, connecting f first derivative and second derivative with the graph of f. So we need to go over some definitions. So one of the definitions is that if y is increasing, the first derivative needs to be above the x-axis. When y is decreasing, then the first derivative, the y, needs to be below the x-axis. If the y has a max or min, then you have a 0. And then if you have a point of inflection, then you're going to have a max and min on the first derivative. Okay, so this is just definition you need to know for today's. Then also some definitions that we need to talk about is first derivative. So when you take the first derivative, you have a maximum and a minimum points, and also increasing and decreasing. If you take the second derivative, then you have this concave up, concave down, and also point of inflection. So these should actually be reviewed from what we just did in part 1, because in part 1, when we took the first derivative chart, remember we did the maximum point, and then from there we did the increasing and decreasing. Then the second derivative chart, we did the concavity on the chart right there. Okay? So on today's homework problem, we're going to take something like this, a graph, and we're going to graph the derivative graph. But before we do this, let's go back to this definition and ask yourself is how am I going to approach this problem? So the first thing you probably should do is look for a maximum minimum. I would consider that that's the first step you should do. Then from there, you should probably look for is point of inflection, if you have a point of inflection in that graph. And then next is the increasing and decreasing. So those are numbers 3 right there. That's the third approach right there. So that's the approach that you should have when you go ahead and graph this out. So again, then from here, we're looking at this right here, and I ask myself, remember the first question is, do I have a max or min? So in this problem right here, do I have a max or min? Yes, I have a min down here, right? So this is the min. So if this is a min right here, we said the first derivative for a max or min is a 0. So for this part right here, you're going to go straight down. This is a 0. Remember, anything on the x-axis is called a 0 right there. Okay? The next part you should ask yourself is, do I have a point of inflection? Remember, that's number 2 right there. So when I look at this right here, it's not a point of inflection. So I move on to the next part. Do I have an increasing and decreasing? Yes. So this part right here, we always read from left to right when we read graphs. So starting from the left right here, this is decreasing, right? So decreasing in this part right here says it's below the x-axis. So then I start from down here, below the x-axis is decreasing, and it's going up to this dot right there. We like the zeros on the x-axis because that gives us like a goal or a target to get to. And so the next part of that graph that we have then is this part right here, which is increasing, and increasing in first derivative says that it needs to be above the x-axis right there. So then it's above the x-axis right there. Okay, so then we put a little arrowheads just because there's arrowheads on this parabola right there. Okay, so that's this first example. Now example number 2, doing the same thing. We look at this right here and ask yourself, first thing we have is max or min, right? Because that's number 1 right there. Okay. So do I have a max or min? Well, sort of. I do have is a max up here, and I have a min over here, right? So then from there, I could go ahead and put zeros. So I'm just going to go straight all the way down to the x-axis, put a 0 right there. Do the same thing for this one. Go all the way down, put a 0 right there. Okay? So the next thing I ask myself is, do I have a point of inflection? So that's right here. Point of inflection says that it becomes a max or min. So on this right here, definition of point of inflection is that when the two concavities meet. So as we did in our chart right there, this is going to be concave down because it's going to go downwards right there. And this is concave up right here, right, because it opens up right there. So where the 2 meets right there, that's called a point of inflection because it's concave down meets the concave up right there. That's point of inflection. So I'm going to call this POI for point of inflection, okay? So with point of inflection, we said the first derivative of point of inflection becomes max or min. So I'm not quite sure if this is max or min. So for this right now, I'm just going to put asymptote kind of like lines right there to remind myself when I get to that point, I need to make sure at that location there's a max or min, okay? So the next part now is doing the increasing and decreasing. And again, we read the graph from left to right. So starting from the left right here, we read this right here. This is increasing, right? So if this is increasing, We said increasing is above the x-axis. So I start from here above the x-axis, as long as it's somewhere above the x-axis. And I like the 0 right here because that's where my goal is. So here we are at the 0. That's my goal right there. And then from here, this is all now decreasing because it's going below now, right? So it's decreasing. And if it's decreasing, we have then it's below the x-axis right there. So here we are, is below the x-axis. So here's again why I like the zeros. It's from here, my goal is to get to this part right here. And I know it has to be below the x-axis, and so this line right here reminds me it's a max or min. So obviously from here to here, I have to make a U-turn, right? So if I have to make a U-turn to come back up right here, this has to be a minimum right here, right? I can't put it up here, because then this would have been increasing instead. If it's increasing, it's above the x-axis, but if it's decreasing, it's below the x-axis. So that's why it's below the x-axis, and I know I have to make a U-turn because that's my next goal right there. And so this right here tells me there's a max or min. Obviously, this has to be a min because I made a U-turn right there. Okay? Then all of this right here is increasing, and we said increasing right here is above the x-axis. So here we are above the x-axis right there. Okay, so that's the graph we have right there. Okay, next one, example 3. Now example 3, we have some problem because first of all, we don't have any max and min, and I don't have any point of inflection because again, point of inflection is when the two concavities meet. I don't have that. But I have this funny picture right here where we learned in our first beginning of this chapter that there are places in here that's called not differentiable. So if you remember, there are places, 4 places that are not differentiable. One of the places are corners, right? Cusps. Then we have a vertical tangent and any of the discontinuities. So those are not differentiable. So it's not differentiable at this place right there because that's a corner. And it's not differentiable at this place right there is a corner. So if it's not differentiable, what happens is it becomes an asymptote, a true asymptote at this point. So here we are is an asymptote right there. And same thing with this right here, it becomes an asymptote. So I'm going to draw asymptotes right there. Okay? Now, if I draw asymptotes, then you technically have is 3 separate piecewise graph. You have a 1 right here that's a positive linear equation, 1 that's a y equals something constant right there, and 1 that's y equals negative something right there. Okay? So just think of it that way. So if this is then increasing, it would have to be above the x-axis, right? But it's a linear equation going across. It has to be an open circle right here because there's an asymptote. And obviously this is not a real number, so it has to be an open circle. This right here, if it's a flat line, would have to be at 0. So here we are at 0, and it's just going straight through 0 right there. Okay, and again, open circle on these guys. And then this right here is decreasing, so it's below the x-axis. So here we are below the x-axis, and that's going to be the graph that you have. Now, depending on with that, if there's an arrowhead on that, or if it's a solid line, dot right there. So let's just put solid just to make sure that we have the end conclusion right there. Okay, so that's going to be the graph right there. So again, we're looking for it being max and min. We don't have max and min. I don't have point inflection, but I have 2 places that is not differentiable. So it's not differentiable at those 2 locations right there. So they become asymptotes right there, vertical asymptotes. So then from there, I just take it as 3 separate piecewise graphs and graph it out as piecewise. All right. So this right here, again, the first approach is, do I have max or mins? I have a couple of this in this case. So I have one right here, that's a min. I have one up here, that's a max. And I have one right here, that's a min right there. Okay? So max and mins, we said, right there, max and min become zeros right there. So on the x-axis, we're going to make them zeros. So here we are, 0, 0, and 0 right there. Okay? Next part was, do I have point of inflections? Yes, point of inflection again is when the concavity meets. So here's where is concave up right there. And then this is concave down right there because that's a parabola that's going downwards. And then we have a concave up as well right there. So it's pretty much, I would say, somewhere around here. Let's go with this one right here. And these right here is your point of inflections right there. Okay? Again, point of inflection becomes something max or min. So I usually like to do it lightly is kind of like make this dotted lines right there just to remind myself that something is either max or min at that point when I approach to that point right there. So then from here, we just read the graph again from the left-hand side. So here we are on the left side right there. And from the left hand, it says decreasing. So again, decreasing in our part right there says it's below the x-axis. So I start from the bottom part right here, below the x-axis. And again, I like that 0 right there because that's my goal right there. So below the x-axis means I have to get there. Then this is all increasing. So increasing is above the x-axis. And again, my goal is to go from one dot to the next dot. And in order to get to this next dot, I have to make a U-turn. So then U-turn, then I got reminded that up here, it should be a max or min in this area. So obviously in this case, it would become a maximum right there. Okay? Then this is all decreasing. So again, decreasing is below the x-axis. And again, I like this dot because then I go from here to the next dot. So in this case right here, this point of inflection becomes a minimum because I have to make a U-turn, come around, and then all of this is increasing, which is then is above the x-axis right there. Okay? So that's the graph right there. Now, let's look at this carefully because I know some of you guys are thinking to yourself, how does she do this? How does she know if you're starting from the top, if you're starting from the bottom, and things like that? If you look at this logically, right, because we now know that this is going to be, our function is going to be something similar to y equals x squared, right? If this is a parabola, y equals x squared, and I asked you to find the derivative of this, the derivative of this will be then 2x, right? 2x is a linear equation. So that's what this is right here, is a graph of a linear equation, right? Then same thing with this one. This one right here is a function of y equals x to the third, right? Because it's a cube. So if I asked you to find the derivative of this, derivative becomes 3x squared. So then that's going to be a parabola picture. Ah, there's a parabola right there. Okay? Now again, same thing with this one. This is not differentiable right here. So we had to take it as 3 piecewise. So this right here, if I take it as a piecewise, this is the same thing as saying y equals positive x right there. Positive slope because your run and rise is positive. Then if I take the derivative of this, right, and depending on what that slope is, if we actually know what the slope is, obviously there will be a coefficient in front of that x. But whatever that derivative is, let's say in this case we don't know, we just keep it as x, the derivative of this becomes 1. So that's why we have is y equals 1 right there. Okay? Now this right here is same thing as y equals to some kind of constant number. So let's say 3. If y equals 3 right there, if I'd ask you to take the derivative of y equals 3, it becomes 0. So that's why we have it at 0 right there. Okay? Now the same thing with this one right here. This piecewise right here would be y equals negative x, right? Because it's a negative slope. And if I ask you to take the derivative of this, it becomes a negative 1. So that's why it's underneath down here. Okay? Now this last one right here, a W shape. So we know from pre-calc, this is probably like around x to the 4th right there. If it's a U or a W, it's going to be a to the 4th or even power. If I ask you to take the derivative of this, that becomes 4x to the 3rd, right? X to the 3rd, and it's an S shape. That's where we get this S shape. Okay? So that's what we're doing today is now we're going to go ahead and take the derivative. But again, go back to this rule. Ask yourself, is there a max or min? If there is a max or min, find the zeros for it. Are there any point of inflection? If there are, then go ahead and do the point of inflection. Probably the next thing as what we did with this right here, if nothing applies, ask yourself, is there some place that is not differentiable? If it's not differentiable, you want to put some asymptotes in there. And then from there, just read the graph from left to right. And if it's increasing, it's above the x-axis. If it's decreasing, it's below the x-axis. Okay? So that's the part that we're going to do for this part 2 of the 4.3.